These are your notes for Unit 11, Day 4 of Pre-Calculus. If you would like to see your warm-up, review question, or any homework questions we covered in class, just look at the finished notes. So today we are going to talk about how to take a rational expression, so a fraction that looks like it has a polynomial in the numerator and a polynomial in the denominator, and how to break it up into two fractions or three fractions or four fractions that would have been added together or subtracted to make the original fractions. And we call this process decomposing fractions. So a partial fraction decomposition. So right now, it is in its partial fraction decomposition. So if we wanted to put these together into one fraction, we would need a common denominator. And since our denominators are binomials, the first binomial is missing the x minus 3 binomial, and the second denominator is missing the x plus 4 binomial. So to get a common denominator, we would multiply each denominator by the binomial it's missing and the numerator. So now I have 3 times x minus 3 plus 2 times x plus 4 over x minus 3 times x plus 4. And if I simplify this, I get 3x minus 9 plus 2x plus 8 over, if I multiply out the denominator, I'm left with x squared plus x minus 12. And so one more step, and I would have 5x minus 1 over x squared plus x minus 12. So that would be my rational expression. What we're going to do today is we're going to take that rational expression and try and break it back up into the two original fractions that created it. And so our steps in order to do that, step 1 is you're going to factor the denominator so we can break it back up into its pieces. So we're going to factor the denominator. And if they are different factors, meaning that there's no repeating factors, then the process is a little bit easier. So if I factor the denominator, I would get 5x minus 1 over, that factors into x plus 4, x minus 3. And notice since there's two factors, you're going to break up the original fraction into, if they're linear factors, and so notice 5x minus 1, we would call that linear because if you graphed it, it would make a line. You would break it up into linear factors. So a over factor 1 plus b over factor 2 plus dot, 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 as many factors as you have. So I'm going to break this up into a over x plus 4 plus b over x minus 3. And so I need to figure out what the a and b are to make this expression true. Well, notice if I were to put this back together, this guy, if I wanted to make this into one fraction, the x minus 4 is missing the x minus 3 factor, plus the b is missing the x plus 4 factor, and then when I put them together, the common denominator would be x plus 4 or x minus 3, just like we did up above. Well, now we know that that's equal to the original 5x minus 1 over x plus 4, x minus 3. Well, now the two denominators are obviously equal, so now we need the numerators to be equal. So I need 5x minus 1 to equal a times x minus 3 plus b times x plus 4. So now we're going to be creative on what we would plug in for x. Now notice I want to either make the a or the b go away if possible, because I only have one equation and I have two different variables that I'm trying to solve for. I'm trying to solve for a and b. Well, what if I let x equals 3? Well, if I let x equals 3, notice what happens to that factor right there. It becomes 0. So I'm going to plug in 3 for all of my x's. So I have 5 times 3 minus 1 equals a times 0 plus b times 3 plus 4 is 7. So I have 15 minus 1 is 14. So I have 14 equals 7b, or if I solve for b, I get b is equal to 2. Well, now that I have b is equal to 2, I'm going to pick another creative factor for x. What if I let x equal negative 4? Well, if I let x equal negative 4, notice the b factor will go away. So I have 5 times negative 4 minus 1 equals a. Negative 4 minus 3 is negative 7 plus b times 0. So I get negative 21 equals negative 7a, and then when I solve for a, I get a equals 3. So if I want to decompose this fraction back into its original pieces, I would get, whoops, not that guy, this guy right here, I would get a, which is 3, so 3 over x plus 4, plus b, which was 2, over x minus 3. And that would be the decomposition of that rational expression. And notice that is what we started with. So determine whether the irrational expression is proper or improper. So proper means that it has a lower degree on top. So if it has a lower degree on top, meaning the higher exponent is on the bottom, then we call it proper. If it's improper, then we're going to have to do some long division and divide it back out. And so we want to write this as a sum of two polynomials. So remember, our first step, so the first one is proper. We're going to break this up into its factors. So x plus 2, x minus 1. And so this is going to be a over x plus 2 plus b over x plus 1. And that's going to equal the x plus 5 over x plus 2, x plus 1. So notice the two denominators are the same once we get a common denominator. So I'll multiply this one by x plus 1 and x plus 1. I multiply this one by x plus 2 and x plus 2. And since the denominators are the same, I want the numerators to be the same. So a times x plus 1 plus b times x plus 2 is going to equal x plus 5. Now be creative. Let's let x be negative 1. And if I let x be negative 1, then the a term will go away. So a times 0 plus b times 1 equals 4. So b is going to equal 4. And then let's be creative again. To make the b term go away, I will let x equal negative 2. And then I would get a times negative 1 plus b times 0 equals 3. So negative a is going to equal 3. So a is negative 3. So the decomposition of this guy is going to be negative 3 over x plus 2 plus b was 4, so 4 over x plus 1. And that would be the decomposition of that original rational expression. All right, on the next one, it's improper, so we're going to do some long division. So let's see if we can remember how to do long division. So 6x squared minus x plus 5. Nobody's missing, so I don't need any zero terms. And then divided by 3x minus 2. So 3x times 2x is 6x squared. Then we have 6x squared and minus 4x. And then we subtract. So we get 3x plus 5. 3x times 1 is 3x, and then distribute that out. So I get 3x minus 2. So my remainder is 7, so then plus 7 over 3x minus 2. And so that is going to be its proper rational expression. So notice 2x plus 1 is proper, and then 7 over 3x minus 2 is proper because the higher degree is in the denominator. All right, so let's decompose some more. So again, remember, if there's non-repeated linear factors, and remember, linear factors means the degree is 1, then what you do is your first step is you're going to factor the denominator. And then you're going to break it up into a over factor 1 plus b over factor 2, and then et cetera, as many factors as there are. So this is going to be x over x plus 6, x minus 1 when you factor it. So this is going to be a over x plus 6 plus b over x minus 1. There's two factors and they're different. And then get a common denominator. So I'll multiply this one by x minus 1 and x minus 1. And then this one's missing the x plus 6, so x plus 6, x plus 6. And now notice my two denominators are the same, so I have the numerators need to be equal. So x has to equal a times x minus 1 plus b times x plus 6. Then be creative on what you want to plug in for x. Let's plug in 1 first. So if I plug in 1, I get 1 equals a times 0 plus b times 7. So 1 is going to equal 7b. So 1/7 is going to equal b. And then let's plug in negative 6. So if x is equal to negative 6, then I would get negative 6 equals a times negative 7 plus b times 0. And so a is going to equal 6/7. So when I break this up, I get a over x plus 6, and a is 6/7. So I get 6/7 over x plus 6. And then my b was 1/7. Plus 1/7 over b was over x minus 1. And then remember, when you're dividing, you're multiplying by the reciprocal. So if I wanted to rewrite this, I could rewrite it as 6 times 7, x plus 6 plus 1 over 7 times x minus 1. Either way is okay. So you can leave it as the fractions in the numerator, or you can rewrite it as part of the fraction, the denominator of the fraction in the denominator. All right, what if there are repeated linear factors? Okay, so if a factor is repeated, meaning that you have a term that's been squared or cubed, etc., then you have to do a over, let's say like the factor was x plus 1, so we'd do a over x plus 1 plus b over x plus 1 squared, etc. Or if it was cubed, then you would need x plus 1 squared, and x plus 1 cubed. So each one would get its own numerator. So if I break this up, I can factor out an x from all of the terms, and I would have x squared minus 2x plus 1. And then if I factor that again, I get x minus 1 squared. So notice that x minus 1 is a repeated factor. So I have 3 factors. I have x minus 1, and I have x minus 1 squared. So if I break this up, I get a over x plus b over x minus 1 plus c over x minus 1 squared. So notice I have 3 fractions that would make this, and that's going to equal x plus 2 over x times x minus 1 squared. Let's get a common denominator. So the a term is missing the x minus 1 squared. The b term is missing an x minus 1 and an x. And then the c term is missing an x. So I have a times x minus 1 squared plus b x times x minus 1 plus cx is going to equal x plus 2. So if there is a repeated factor, and notice x minus 1 was repeated, we need a b over x minus 1 and a c over x minus 1 squared. Now let's be creative on what our x is going to equal. Let's let x be equal to 1. So this would be a times 0 plus b times 1 times 0 plus c times 1 is going to equal 3. So c is equal to 3. And then let's let x be 0. So if x is 0, we get a times negative 1 squared plus b times 0 times negative 1 plus c times 0 equals 2. So I get a equals 2. So I have a equals 2 and c equals 3, but I still need to know what b is. So we can just pick any other number. Let's let x be 2. So if I let x be 2, then I would get a, which is 2, times 2 minus 1 squared, that would be 1 squared, plus b, and we don't know b, times 2 times 1, plus c, we know c is 3, and we chose 2 equals 4. So we get 2 plus 2b plus 6 equals 4. So 2 plus 6 is 8, so 8 plus 2b equals 4. So 2b, subtract the 8, you get negative 4, so b is going to be negative 2. So we have our 3 guys, a, b, and c, so let's write our decomposition of those fractions. So it would be a over x, so a is 2, so 2 over x, plus b over x minus 1, so plus, we'll just put minus. So minus 2 over x minus 1. And then c is 3, so plus 3 over x minus 1 squared. And this would be the decomposition of the original rational expression. All right, let's look at another one. Find the partial fraction decomposition of x cubed minus 8 over x squared and then x minus 1 cubed. This is already factored, but notice we have 2 repeated factors. So the x is repeated and the x minus 1 cubed is repeated. So we're going to have a over x plus b over x squared plus c over x minus 1 plus d over x minus 1 squared plus e over x minus 1 cubed. So this time I have to find 5 different fractions. And that's going to equal x cubed minus 8 over x squared times x minus 1 cubed. All right, so a is missing an x and an x minus 1 cubed. The b is missing the x minus 1 cubed. The c is missing the x squared and an x minus 1 squared. The c is missing, the d is missing an x squared and an x minus 1. And then the e is missing the x squared. So now I have ax times x minus 1 cubed plus b times x minus 1 cubed plus cx squared times x minus 1 squared plus dx squared times x minus 1 plus ex squared equals, ex squared equals x cubed minus 8. All right, well, let's let x be 0, because we're going to let x be 0 and x be 1, because those are the twos that will make some terms cancel out. So this would be a times 0 plus b times negative 1 cubed plus c times 0 plus d times 0 plus e times 0 equals negative 8. 0 cubed minus 8 is negative 8. So I get negative b equals negative 8. So b is going to equal 8. All right, well, now I have 1 out of the 5. Let's let x equals 1 and see what happens. So we get a times 1 times 0, so that'll be a times 0 plus b times 0 plus c times 0 plus d times 0 plus e times 1 squared is 1 is going to equal 1 cubed is 1 minus 8. So this is going to be e is going to equal negative 7. So now I have e and b. So now I've got to find the rest of them. So let's rewrite this. So we know e and b now. So this is going to be a times x minus 1 cubed plus b is 8. So plus 8 times x minus 1 cubed. And then plus c times x squared times x minus 1 squared plus dx squared times x minus 1. And then e is negative 7, so minus 7x squared equals x cubed minus 8. All right, so now let's let, we'll pick a different number. Let's let x be negative 1. So this would be a times negative 1, and then negative 1 minus 1 is negative 2 cubed plus 8 times negative 2 cubed plus c times 1 times negative 2 squared plus d times 1 times negative 2 minus 7 times 1 and then equals negative 9. Negative 1 cubed minus 8 is negative 9. So this is going to be negative 8, so this would be 8a, and that would be negative 8, so minus 64 plus 4c, and then minus 2d minus 7 equals negative 9. So this is going to become 8a plus 4c minus 2d is going to equal, that would be negative 71. So add 71, that's going to equal 62. Negative 71. Yep. So looks like we're gonna have a system of equations. And so now let's do it again, but let's do x equals 2. So if I let x be 2, I'm gonna do it over here. This would be a times 2 times 1 plus 8 times 1 plus c times 4 times 1 plus d times 4 times 1 minus 28 is going to equal 0. So I get 2a plus 8 plus 4c plus 4d, that's minus 28 equals 0. So I get 2a plus 4c plus 4c plus 4d is going to equal 20. So there's another system. So part of my system, 2a plus 4c plus 4d equals 20. And then we're going to have to do one more. Let's let x be 3. So if I let x be 3, I'll get a times 3 times 8 plus 8 times 8 plus c times 9 times 4 plus d times 9 times 3 minus 7 times 9 equals 27 minus 8 is 19. So this is going to be 24a plus 64 plus 36c plus 27d minus 63 equals 19. So we've got 24a plus 36c plus 27d equals 18. So 24a plus 36c plus 27d equals 18. So now I have a system of equation with 3 variables. I am going to eliminate my c's. So I'm going to take these 2 equations and subtract them. And I would get 6a minus 6d equals 42. And then I'm going to take these 2 equations. I'm going to multiply the top one by 9. And so I would get 18a minus 24a. I would get negative 6a. I would get 36 minus 36 is 0. And I'd get 36 minus 27 is 9. So minus, positive 9. So plus 9d equals 180 minus 18 would be 162. And then I would add to eliminate my a's. So I would get 3d equals 204. And then I would divide everybody by 3. And I get d equals 68. So I have d is equal to 68. And then I can plug that back in and solve for my a. So I would have 6 times 68, and then I would add that to 42, and then divide that by 6. Oops, 43. I got to add it to 42. And I get a is 75. And then to find my c, I could use a and d in that middle equation. So 2 times 75 plus 4 times c plus 4 times 68 is going to equal 20. So I'm going to do 20 minus 4 times 68, and then minus 2 times 75. Then I'm going to divide that by 4. Minus 4 times 68 minus 2. So my c is going to be negative 100.5. So as long as all of my math was correct, I found my a, b, c, and d. So my partial decomposition would be my a was 75, so I would have 75 over x, plus my b was 8, so 8 over x squared, plus my c was negative 100.5, so over x minus 1, plus my d was 68, so that would be over x minus 1 squared. And then my e was negative 7, so that would be over x minus 1 cubed. There was a lot of places where I could have made a little math mistake in there. But notice if there are repeated factors and you end up with, in this case, we had 5 fractions, you're going to have a system of equations that you're going to have to solve in order to find the missing numerators. All right. What if your factors aren't linear? So if you have quadratic factors, so if you have a factor that involves an x squared plus bx, so not just an x squared, but an x squared plus bx plus c factor. So if you have that, then in your numerator, instead of just having a, you'll have an ax plus b as your numerator. So if I factored this, notice I have a difference of cubes on the bottom. So I would have x minus 1, and then x squared plus 1x plus 1. So those would be my 2 factors. And notice that that is a quadratic factor. And then this one is a linear factor. So my 2 fractions would be a over x minus 1, and then bx plus c over my quadratic factor, x squared plus x plus 1. So again, your quadratic factor will have a bx or an ax or an ex plus a constant. So you'll have a linear factor and a constant factor. All right, and this is going to equal 3x minus 5 over x minus 1 times x squared plus x plus 1. So just like we did before, the x minus 1 is missing the x squared plus x plus 1 factor, so multiply the numerator and the denominator. And then the x squared plus x plus 1 is missing the x minus 1 factor. And so now we have a times x squared plus x plus 1 plus bx plus c times x minus 1 is going to equal 3x minus 5. And just like we did before, we want to be creative. So let's let x equal 1. And if I let x equals 1, then I get a times 1 plus 1 plus 1 plus b times 1 plus c times 0 equals negative 2. So we get 3a equals negative 2, so a is going to equal negative 2/3. So that's going to be my a factor. And then let's let x be 0. So if I let add a page here. If I let x be 0, then I would have a times 1 plus b times 0 plus c times negative 1 is going to equal negative 5. Well, we know a is negative 2/3, so negative 2/3 plus c times negative 1 is going to equal negative 5. So I'm going to add that 2/3 over. So I have negative c equals negative 5/3 plus 2/3. So we're going to have, we'll get a common denominator. So times 3, so that'd be negative 15, so negative 13/3. So c is going to be 13/3. So now I have my a and my c. And now we're going to find our b. So let's pick another value. So let's do x equals negative 1. So we have a times 1 minus 1 plus 1 plus b times negative 1 plus c times negative 2 equals negative 8. Well, we know our a is negative 2/3, and then times 1 plus negative b plus c, which would be 13/3 times negative 2 equals negative 8. So I have negative 2/3, distribute that negative 2, plus 2b minus 26/3 equals negative 8. So we have negative 28/3 plus 2b equals negative 8. Let's add the 28/3 to the other side. So I get 2b equals negative 24/3 plus 28/3, which would be 4/3. So 2b equals 4/3, divide by 2, and b would be 4/6 or 2/3. So I've got my three numerators now, well, my three variables. So when I break this back up, you had a over x minus 1, and a was negative 2/3, so negative 2/3 over x minus 1, then plus bx, so 2/3 x plus c, which was 13/3, over x squared plus x plus 1. And that would be the decomposition of that original rational expression. All right, what if there are repeated quadratic factors? So we would handle these the same way that we handled our repeated linear factors. So notice the x squared plus 4 is a repeated quadratic factor. And so when I break this up, since they're quadratic factors, I have an ax plus b over x squared plus 4, and then plus a cx plus d over the x squared plus 4 squared. That's going to equal x cubed plus x squared over x squared plus 4 squared. All right, so why don't you guys see if you can figure out the A, B, C, and D in order to find the partial decomposition of this rational expression. So go ahead and pause the video and try, and then you can check your work against the finished notes from class today. All right, your homework is from 11.5.